So let's quickly look at this question we have before us here. So we're actually going to be looking at, we want to calculate the engine of a car provides a forward force of 1,240 Newton and a total resistance force of on the car is 800. That means as the car is trying to pull forward with a force of 1,240, there's a backward force that is pulling it at 800. So if the mass of the car happens to be 1,220, determine the distance the car has to travel from the rest before acquiring a speed of 4 meters per second. So that's the question. And let's see how to go about it. So the first thing we'll try to do here is to make sure that we have a formula which states that force is equal to mass times acceleration. Now, in this case, we're going to be having a forward force, F subscript F, then we have a backward force. So this backward force is the one pulling it back. So this is going to be equal to MA. So that means this is a resistance force. So that means the main force that is pulling it forward is 1,240, then minus 800, which is the one pulling it backward, equal to MA. So the mass was given to us. The mass was given to be 1,220. So that becomes 1,220. So we have 1,220 acceleration. So we have to subtract this from this. So 1,800, 1,200 subtract 1,240 subtract 800. So that's going to give us 440. Then equal to the acceleration here is going to be equal to 1,228. So we can get our acceleration by dividing both sides by 1,220, then 1,220. So therefore, our acceleration will become A equal to 440 over 1,220. So we can just reduce this to its lowest term, which means we have 44 over 122 meter per second square. So that's the acceleration. Now we know what the acceleration is, but we're actually asked to calculate the distance. So we go back to our Newton, our equation of motions. Let's look at those that involves distance. X is equal to ut plus half at square. That's one. There's another formula that says v square is equal to u square plus 2as. There's also another formula that says s is equal to v plus u all over 2 brackets t. Then you determine which one to use. So based on what we can find here, we have our acceleration, and we also have the speed. We also have a speed. So they said from the rest before acquiring a speed. From rest means that our initial velocity is equal to 0. That means initial velocity is 0, then final velocity is 4. And we have as an acceleration of, what do we have, of 44 over 122. So, and also, we also have the time. The time factor was also given to us. Let's see. They said a forward, a resistance, determine, okay, no time was given to us. So which one are we to use in this formula? So I think this will go for it. Is that okay? So we're going to be using this formula of v square equal to u square plus 2ax, where x stands for the what? Distance. So the final velocity here is 4, which is 4 squared. Initial velocity is 0 plus 2 times acceleration. We got acceleration of 144 over 122, then times what? The distance. So if we do that, we're going to have 16 equal to 2 times this. That will give us 88s over 122. So this is just mere mathematics. When we multiply both sides and divide both sides by 88, we're going to have 16 times 122 over what? 88. So we can quickly check use our calculator to figure that out. So I have 16 times 122 equal to, then divide 88. So that will give us 22.18, which is approximately 22.2. So this is 22.18, approximately 22.2 meter. So this is actually the correct value. So this is correct. So this is how we actually go about solving problems like this.